JamSense is a new tool that is aimed towards interference and jamming classification for low-power wireless networks. It makes it possible to detect 4 of the most common jamming attacks, which are the constant, deceptive, random, and the reactive jamming attack of any kind. These jamming attacks are possible to categorize in 2 different categories, being the proactive and reactive category. A proactive jamming attack is proactive and uses more or less a brute force approach, while a reactive jammer reacts to something that is happening. In our case, did we use the start of frame delimiter jammer, which listens to a channel. When it senses a packet start of frame delimiter right after the preamble, will send out a burst of signals that will corrupt the payload of the packet and force the receiving node to drop it, which results in interference. The constant and deceptive jammer are very similar. The constant jammer sends out a constant signal of bits, while the deceptive jammer sends out packets which contains a preamble and start of frame delimiter. Both jammers jam by having a stronger signal power and outperforms the 2 nodes communicating. The random jammer jams for a random amount of time and then stays concealed for a random amount of time. JamSense consists of 4 different parts. The first part is the RSI sampler, which reads in the RSI signals in the environment, quantizes those values and run length encodes them. This creates 2 vector, which consists of the strength of the signal and the duration of the signal. These 2 vectors are then clustered by a k-means clustering algorithm that uses a weighted Euclidean distance algorithm, which job is to create clusters of 2 vectors that are similar. The third part is interference classification. This part compares the clusters to predetermined thresholds that have been profiled earlier. If the cluster is between the threshold, do we have a match? It is also possible to identify unintentional interference such as Bluetooth and Wi-Fi. This follows a similar approach, but instead of creating 2 vectors, we create bursts that are clustered. A burst is the weighted mean power level and the total duration of the subsequence. We will now demonstrate JamSense when it detects and identifies the different jamming attacks. Here we can see it is set up. It consists of 3 different nodes. On our F5284 development kit, which has an antenna connected to it. This device will send out the different jamming attacks. 2 on our F5284 dongles, one which runs JamSense and one which runs RSI scanner, which will help to visualize the different attacks. There is approximately around 1 meter from the jamming source and JamSense. Here we can see JamSense and the RSI scanner in action. If we take a look at the RSI scanner, which is to the right, we can see that there aren't that much traffic going on. Every mountain represents a signal, and the higher the mountain, the stronger is the signal. In the left window, do we see JamSense looking for jamming attacks on one channel. We can see that it creates clusters, but it doesn't display any traces of a jamming attack. If we turn on the constant jamming attack, we can see that a lot of noise is created, and we can also see that JamSense is detecting the constant jamming attack. Because of the random jammer cannot display directly that a constant jamming attack is occurring, because a random jammer can take on the shape of a constant jamming attack in worst case. Therefore, do we need to check for consistency. If a cluster's attributes are inside the predetermined threshold, we save the cluster in a cluster sample. When 5 cluster samples have been collected within a certain time duration, their average and each cluster's difference to their average is calculated. If the difference is smaller than a certain threshold, meaning that the sample values are close enough to each other, JamSense concludes that the cluster sample is not a random attack, but either a constant or deceptive jamming attacks, as these attacks are consistent, which is happening in this case. If the difference is larger than the threshold, JamSense classifies the attack as a random jammer, as random jammer are inconsistent. The difference in identifying the constant and deceptive jammer is to check if the packet contains a start of frame delimiter or not. In this case, do we execute a random jammer? You can see on the right on the RSI scanner that there are a random amount of time the jammer is active. JamSense stores the cluster samples that are suspicious, check for inconsistency in between the bursts of jamming attacks, and by doing that is it able to identify if it is a random jammer attack. The last jamming attack is the reactive jammer, which only attacks if it senses a packet being sent on the channel. In order to trigger the reactive SFD jamming attack multiple times, we add a third node to the setup, which sends out a packet every second. The node's goal is to trigger the reactive SFD jammer. Behind the RSI viewer window to the right, you can see a window printing send packet size. That is a node sending out packets every second and triggering the reactive SFD jammer. Note that the RSI viewer is not able to visualize the reactive jammer. The reactive SFD jammer attack operates for a very short duration, but JamSense is able to identify it, as we can see to the left. JamSense is built upon another tool that is called SpecSense. Keeps its ability to identify unintentional interference as well. On the RSSI viewer to the right is it possible to see the normal environment. We placed two Bluetooth devices around 1 meter from JamSense and transmitted a file through Bluetooth. It's possible to see on the RSI viewer that a lot of activity is starting. JamSense in the left window does also show the possibility to identify Bluetooth interference. In order to create deterministic Wi-Fi interference, it will use a firmware called JamLab NG that runs on a Raspberry Pi. The Raspberry Pi is placed around 1 meter from JamSense. You can see on the RSSI viewer that activity is forming, and it's possible to see to the left that JamSense is able to identify Wi-Fi. We measured the accuracy of JamSense identifying the different jamming attacks and got an accuracy of 96% for the constant and deceptive jammer, and around 90% for the random and SVD jamming attacks. For identifying Bluetooth and Wi-Fi we get an accuracy of 87 and 86%, and 85 and 88% for identifying Bluetooth and Wi-Fi when they are active simultaneously. That concludes JamSense. Thank you for listening.